Okay, for lesson 5.5, we're going to be talking about something called the law of sines. Now, while you're working on this section and the next, just to make sure you're referring back to your property sheet like we got in chapter 5. It's on the back side. All the formulas you'll need will be right there, so you might want to have that or pull it up in your Chromebook or print it out, one of those things. We are going to be referring back to this oftentimes. But the law of sines, what we do with that is we're going to use it to solve a triangle. Now, these triangles are not going to be right triangles. They're going to be oblique triangles, which mean triangles that don't have a right angle in them. So it's a little different than what we've done before. That's why we have this new formula. What it's going to do for us is it's going to help find all three angles and all three sides, as long as we're given at least three of those to begin with. The information that we're going to be given has to do with, it corresponds to these acronyms that you might remember from geometry. AAS, ASA, meaning angle, angle, side, angle. Those are a couple of acronyms that we use in geometry to prove triangles congruent to each other. There's also this other one, SSA, and if you remember from geometry, that's the one that we couldn't use to prove triangles are congruent. So this one's going to be a little trickier. It's going to take a little bit more of our time. This is called the ambiguous case, and we're going to go through all of these in examples here later on. But one thing I do want you to notice about this triangle is that the angles are lettered A, B, and C in capital letters, and then the sides across from them are the same letters as big B across from little b, big A across from little a, big C across from little c. And you're going to see that set up each and every time when we do these examples. Here is another look at it, and this is where we see the law of sines. So the law of sines is actually this formula right here. That formula, even though there's more stuff than we need, we're going to pick two each time. So we might pick the A and the B part and put those together because we're trying to just solve for missing pieces. We don't want all three at the same time. So we might, and also one thing that's kind of nice about this is that we can flip these over. We can take the reciprocals of all these fractions, and so I could do an equation that's little a over sine A equals little b over sine b. That would be a possibility as well. The other thing that I'll point out from these pictures that you see right here, we've got maybe looks like an acute triangle and an obtuse triangle, is that both of them are indicating a height. There will be times throughout our examples that we will want to find the height, and we're going to do that just by normal trigonometry. Think about making a right triangle in there with that height, that dotted line. So if we wanted to involve h, we could do sine of A equals h over b. And you might notice that this is close to this expression up here. We just multiply by b to solve for h, and so that's what this expression means. This one would just be taken from if we were using angle b. Over here, we're just using angle A to get the height, and so it's all the same kind of thing, but there's an expression in each one in case we're trying to find the height. So that's one thing that we'll be doing from time to time in our examples to determine what comes next.